right, so we're continuing on lesson 2.2. We're on example 5. So on example 5, it's kind of the reverse of what you were doing the previous lesson. So we have the zeros, and we're going to find the polynomial function that has those zeros. So the first thing that you would want to do is name your function, whatever you want to name it. I'm going to name this one f of x. And then we're going to take the zeros and turn them into factors. And there's always more than one answer here, but I try to do like the easier version. So if 0 is one of the zeros, a factor, that would give you a 0 of 0 is the factor x. Now, if you wanted to make it x squared or x cubed or whatever, you could change the multiplicity of it, but the factor is x. And then for a 0 of x minus 3, that factor is going to be x plus 3. And again, we could put a power on those parentheses if we wanted to. I do not want to. It just would make it more difficult to do if we do it that way. And then the factor that would give you a 0 of negative 7 is x plus 7. All right, so then I would just take a minute and we're going to multiply these 3 factors together, but we can only multiply them one pair at a time. So I am going to just multiply these 2 together, and I'll let that x hang out in the front, and when we get done multiplying those, we'll distribute the x. So I'll just distribute x and distribute 3 and combine my like terms, and then finally I would distribute this x. Right? So that is a function, not the only function, but a function that has zeros of 0, negative 3, and negative 7. Now, if you wanted to make sure that you were right, sorry, I have a bunch of stuff open, you can look on the, if you had a graphing calculator, you could look on the calculator. Mine didn't want to. Okay, and we will go to y equals and type that function in. And when we look at the graph, this graph has a 0, a negative 7, a negative 3, and a 0. So we have filled what we needed to do. All right, so let's go to the next one. This has a few more zeros. So I'm going to call this one g of x. You have to call it something, or it's not a function. So f of x, g of x, h of x, p of x. You can just call it y if you wanted to, but it has to have a name and it has to be equal to something. Otherwise, it's just an expression and not a function. All right, so a 0 of negative 2 is going to have a factor of x plus 2. A 0 of 0 has a factor of x. A 0 of 2 is going to have a factor of x minus 2. And a 0 of 3 is going to have a factor of x minus 3. Now, I'm going to rearrange these because I noticed that x plus 2 and x minus 2 are going to be a lot easier if we multiply those together. And then I'll multiply the x by the x minus 3. That's just going to just make it easier for us. It doesn't matter because you can multiply in any order, and it's just going to get the same solution, but I know because it's x plus 2 and x minus 2, I can multiply using the shortcut because when I multiply the outside and get negative 2x, is going to cancel out with the 2x. So this is just going to be x squared minus 4. Over here, I'll distribute the x. Right, and then finally, I will multiply those together. So I'll distribute x squared, and then I'll distribute negative 4. And you don't have any like terms, so that is your function. All right, so those two I feel like are ones like you probably did in Algebra 2. This next one we're going to do, I'm fairly certain you didn't do any as difficult as C in Algebra 2. So I'm going to call this one Y. Okay, so we need to find a factor that would give us a 0 of 1 plus the square root of 2. Now in all the other ones, we would just have the x, and we would just do the opposite. So we're going to do the same thing, but we need to make sure we do the opposite of both of these. So it's going to be x minus 1 minus the square root of 2. All right, and then same thing for the other one. We'll have an x, and we need to do the opposite of both of these. So x minus 1 plus the square root of 2. Now, to multiply these together, we can just distribute x, distribute negative 1, distribute negative square root of 2. But it's easier if we use like this little grouping method that I like to do. So these both have an x minus 1. So I'm going to group x minus 1 together. All right. Then it's kind of like what we had when we had x plus 2, x minus 2. We had the same terms, so the different sign in between, so we would just do a shortcut distribution. So this is the same thing. We have the same terms, x minus 1, negative square root of 2, positive square root of 2, just the same terms, different sign in between. I can do shortcut distribution also, so I can just multiply the x minus 1's together and then multiply these together. So when I multiply x minus 1 times x minus 1, I'm going to get x minus 1 quantity squared. And then when I multiply the negative square root of 2 by the positive square root of 2, I get the negative square root of 4, or just minus 2. Right? And this is where I would like you to use the shortcut for squaring binomial, where we square the x, multiply them together, and multiply by 2, and then square the 1. Right, and I brought down my minus 2, and then finally, I have my function x squared minus 2x minus 1 by combining my like terms. Right, so that's a little more challenging than probably than what you did last year, and that's good because you need to learn new things. All right, and then D is a little different. So we have 2 zeros, but the function is degree 3. So if you just multiply 2 zeros together, you aren't going to get a degree of 3. You're going to get a degree of 2. So what we have to do is make one of those a repeated 0. So it's up to you. Do you want to make negative 1 have a multiplicity of 2, or make the 4? It doesn't really matter. 1 is smaller than 4, so I'm just going to go ahead and have the x plus 1 be the repeated factor. All right, so I'll go ahead and square x plus 1, kind of like what we just did, but it's a different sign in between. All right, then I'll distribute. I'm going to distribute from the right, so I'm going to distribute x. And then I'll distribute negative 4. All right, so let's just look at this graph for a second. So right here, I have a 0 of -1, and here I have my 0 of 4. But this one is the one where it just touches and bounces back because it has an even multiplicity, so it repeats. There's 2 factors, so multiplicity of 2, so it's just going to touch it and bounce back. And this one goes all the way through because it has a multiplicity of 1. All right, and then in example 6, we're going to put everything together. So first, we're going to do a sketch, but we're going to start off with the leading coefficient tests. So this one has an odd degree, it's a degree of 3, and a negative leading coefficient. So try to remember that the leading coefficient tells you what happens on the right. So because the leading coefficient is negative, we're going to be falling on the right. And then because the degree is odd, the left is going to do the opposite. So that's my end behavior. All right, B says to find the real zeros. So I'm going to take the function, I'm going to set it equal to 0, and solve it for x. So start off, I'm going to factor out a negative x, because I'm at least going to try to factor this, and I want my leading coefficient to be positive. Okay. Now, I think I've taught you guys about the Prizer rule of 4, but if not, I'll talk about it right now. If you're factoring and this coefficient is a 4, the way to get 4x squared, obviously, is 2x and 2x, or 4x and 1x. So what you have to do is look at this number. If it is even, it's going to be 2 and 2. If it's odd, it's going to be 4 and 1. So this one, 100%, is going to be 4x and x. All right, and then I know my signs are different because I have that -21. Now I may have to switch those in a second, but I'm going to do plus minus to begin with. And the only way to get 21 is 1 and 21 by multiplying 1 and 21 and 7 and 3. And so we could play with different things. If we want to get 5, probably not going to be 1 and 21. What works is this, because we get negative 12x plus 7x. Oh, I messed up. Hold on. I didn't factor a negative out of the 5. Let me fix that. All right, so now it is right. Negative 12x plus 7x gives you the negative 5. Okay, so I would love for you guys to just be able to look at the factors and tell me the zeros. So a factor of negative x is going to be a 0 of 0. For 4x plus 7, we do the opposite sign, and then we will take 7 and divide it by the 4. Okay. And then for a 0 of 3, for a factor of x minus 3 is going to be a 0 of 3. All right, the C part is I would say, without using a graphing calculator, is definitely the most tedious part. But you will have these to do on your test without being able to use a calculator. So what we want to do, I'm going to go ahead and graph a little bit. Hold on, let's do this last. Okay, so don't label the scale on your y-axis yet, but let's do the x-axis. I know I have a 0 of 0, and then I know I have a 0 of 3, and I have a 0 of negative 7/4. So negative 7/4 is almost negative 2. That's just going by ones. So what I would want to do for C is just find some more points. All right, so I would probably want to figure out what's going on the graph between -2 and 0, so I would put a -1, I would probably go ahead and put in 1 and 2 just to kind of see what's going on. Now there's one more thing we could do. We probably should have done this at the beginning, sorry. So I know that on the left side of the graph, I'm going to have an arrow pointing up because I've already figured this out. And the right side, I'm going to have an arrow pointing down. We just have to figure out what's going to happen in the middle. And I know it's going to cross at those points, but let's see what else is going to happen. So we would take -1 and we put it into the original. So we would cube it and get -1, multiply by -4 and get 4. We would square it, get 1, multiply it by 5, and then we would multiply it by -1 and then put all those together. We should get -12. Right. Do all the same thing with 1, put it in for the function, we get 22. And when we put in 2, we get 30. Okay, so when I do my scale, I'm just going to go by tens because I know I need to get to 30. All right, so I'm going to have a point at -1, -1, -12, at 122, and at 230. Now, I don't know if 30 is the highest it goes. I haven't found relative max. It's fine. We're just getting a little sketch. So we're going to go through the 0 there and then curve through these points, through those points. Boom. Now, that's not the most beautiful graph in the world, but you get the idea. We do want to make sure that our functions are continuous because these are polynomial functions, and they have smooth, rounded turns, which this one does. It's not perfect, but these should not have pointy corners, sharp edges. Okay, so let me give you guys your assignment on page 134. I want you to do 60, 62, 63, 65, 68, 78, and 82.